So now that you have copied down the graphic organizer that is shown in the text, we're going to go into a little more detail about each of these types of numbers. In your journals, I want you to draw a vocabulary square for each type. In each one, you're going to write the definition, a numeric example, a real-life example, and a non-example. We'll fill in the first few together. I made mine inside each of these circles so you can really see which set of numbers we're referring to and how they all fit together. I don't expect you to be able to squish this into your own diagram and your journal, so you guys are just going to draw these over to the side. But since I can zoom way in this program, I put mine on the inside. Let's start with natural numbers like the text does. Make sure your vocabulary term is written in the middle of the chart. Please copy down what I write up here. First, I'm going to put my definition for natural numbers in the top left. The text says that another name for natural numbers is counting numbers. So now for my numeric examples. Like the text says, these are numbers like 1, 2, 3, and so on. These are the numbers that come to us naturally when we learn how to count. In fact, some people have given these numbers the nicknames Sesame Street numbers or Elmo numbers. So what's our real life example? The text says that this could be like a farmer counting his sheep. He might have 1, 2, 3 sheep or more. It's always a nice round number. The farmer's not going to have half a sheep. So now we have to write a non-example. This is something that is not an example of a natural number. The text said that these are like the counting numbers that don't include 0. So that means 0 is not a natural number. I'm going to write 0 as my non-example. 0 is not a natural number. Okay, so that's all our information about natural numbers. Let's move on to the group that's a little bigger. The next one is whole numbers. We know that whole numbers include all of the counting or natural numbers plus something else. What other thing do we need to add? That's right, 0. So what do you think we should write for our definition for whole numbers? I think natural numbers and 0 sums it up pretty well. It's just the natural numbers we were already talking about and 0. So now we need some numeric examples of whole numbers. Who can give me some whole numbers? Yeah, it's just like before, but with 0. So 0, 1, 2, 3, and so on. So what about a real-life example of whole numbers? Who has some suggestions? Well, for me, I picked the number of marbles in a jar. You know those contests where you have to guess how many marbles are in a jar? It's always going to be a whole number, but it could also be 0. It could be an empty jar with 0 marbles in it. Can someone suggest a non-example? What's something that is not a whole number? Ooh, 1/2. That's a good one. You're never going to find half a marble in one of these jars. Okay, let's move on to the next one, which is integers. Integers include the whole numbers and the natural numbers inside, plus some more. What's something else that we add into to make it integers? You could say it's all the whole numbers from before, as well as the negative numbers. Because the whole numbers don't include negatives. You're not going to have -4 marbles in that jar. So what's our numeric example? Who can suggest some? Yeah, it's like 0, 1, and 2 like before, but it also has negative numbers, so like -1 and -2 go in the other direction. So what's a good real-life example for integers? What's something that we do in everyday life that has negative numbers in it? Well, one example would be temperature. If the temperature is below 0, it's suddenly in negative degrees. So that's one that we come across all the time. And what about a non-example? Something that is not a negative or positive, like whole number. It might be, yeah, like -3/4, because that one is a fraction. Fractions are not integers. Fractions come into the next group, which is rational numbers. So now what you're going to do for your chart for your rational numbers and your irrational numbers is you're going to work in pairs to fill in your own charts. So I'm not going to tell you what I put in mine just yet. So you're going to pair up and you're going to come up with your own definition, your own numeric example, your own real life example, and your own non-example. And then after you work together for a few minutes, we're going to come back together and we're going to share what we all came up with.